right? If you're working with a rational power, okay, you could either, and same with the radical, you can always turn a radical into a rational power, and you can work with them the same way. But the idea is going to be the exact same thing. Treat it as a fraction in the numerator, fraction in the denominator. We can combine our fractions here. And we could also use the LCD method for this. Either of the methods will work. Okay, but if we were to combine this numerator into one single fraction, what would our LCD be? 5w plus 3 to the 3/5. And so when we multiply this first fraction, 5w plus 3 to the 2/5 times the LCD factor missing, 5w plus 3 to the 3/5 minus 4w times what LCD factor was missing from the second fraction's denominator? Nothing. Okay, and so here we could simplify. When you multiply two exponents with the same base, what do you do with their powers? 2/5 times 3/5 is 5/5, so this gives you 5w plus 3 to the first, 5/5 or first, minus 4w all over 5w plus 3 to the 3/5. So if we continue to simplify the numerator here, 5w minus 4w gives you w plus 3. So this right here would be our numerator written as a single fraction. We can then invert and multiply by the reciprocal, 1 over 5w plus 3 to the 3/5, giving you across the top w plus 3. And across the denominator, again, you have these exponents with the same base. So what do you do with their powers? 3/5 plus 3/5 is 6/5. Once again, notice I have radical in my denominator, right? Rational powers are radicals, right? I'm not asking you to identify domain restrictions here, but and you can leave radicals in your answer. All right, I'm going to show you another method to approach these, okay? And that method is factoring. Okay, so you could use LCD. You could use what I showed you here, combining fractions. You can also use a factoring method. And if you factor, okay, and this one's a little bit harder to figure out how to do it, but if you know how to do it, it's quicker and easier to use. Okay, so once again, there's pluses and minuses with choosing one method over another. But if you're going to use factoring, what you're going to do is express any complex fractions as negative powers. Okay, so the other way I could write this problem up is I could say the following. 5w plus 3 to the 2/5 minus 4w times 5w plus 3 to the what? Negative 3/5. Okay, all over 5w plus 3 to the 3/5. Okay, so I could express my fraction in this form. If I did this and I saw that I have this common binomial, 5w plus 3, I can take that out as a common factor. Anytime you remove something as a common factor, the original form, in this case the difference of two groups of factors, has to be maintained. So I have something minus something else when I remove my common factor. And anytime you factor, you always take out the lowest power. Okay? The tricky thing with this, and why it's more complicated to understand it for many students, is when you're dealing with negative numbers, what number is lower, 2/5 or negative 3/5? Lower means further to the left on a number line. So the negative, right? So negative 3/5 is lower, so that's what I'm going to remove as my common factor. If I choose to do it this way, when I look at what's left inside my factors, dividing, when I divide this out as a common factor, when you divide exponents with the same base, you do what with their powers? Subtract, right? So I'm going to subtract a power of minus 3/5, subtract a power of minus 3/5 to see what's left inside my groups. So what's 2/5 minus a minus 3/5? 5/5, which is 1. So I'm just left with 5w plus 3 to the first in my first group. In my second group, I have my 4w. And what's negative 3/5 minus a negative 3/5? Minus a minus becomes a plus, right? So those cancel. 0. 0/5 is just nothing, a value of 1. So I'm left with just the 4w here, all over 5w plus 3 to the 3/5. Stays in my denominator. Now notice what I can do when I simplify this. I have my negative power that came out. If I move this down to the denominator now, it moves down as 5w plus 3 to the what power? 3/5, right? When I move it from the numerator to the denominator, I change its power from a negative to a positive. Okay, and so if I simplify what I have, 5w minus 4w is w plus 3 all over in my denominator. I have exponents with the same base, so what can I do with their powers? Add them, and notice I get the same answer. Okay? Now, technically I wrote a little bit less when I factored. Okay? At the same time, it took a little bit more understanding to work through that as factors. But you can do that with both the radicals and rational powers. Okay?